A tree is symmetric if its left half is a mirror image of its right half, like a shape folded down the middle. Picture a root 1 with 2 on each side, and under the left 2 the value's 3 then 4, while under the right 2 they are 4 then 3, flipped. That folds perfectly, so it is symmetric. Let's write the test. Symmetry is really a mirror comparison between the root's 2 children. We write a helper that takes 2 nodes and asks, are these mirror images? If both are empty, yes. If only one is empty, no. If their values differ, no. Otherwise, and this is the key, the outer sides must mirror, so the left node's left child pairs with the right node's right child, and the inner sides must mirror too, so the left node's right child pairs with the right node's left child. The whole tree is symmetric when its left and right children mirror each other this way. Main function says an empty tree is symmetric, and otherwise checks whether the root's left and right children are mirrors. The helper compares 2 nodes. Both empty is a match. Only one empty is a mismatch. Differing values is a mismatch. And otherwise the outer pair, left's left with right's right, and the inner pair, left's right with right's left, must both mirror. Let's write the symmetry test and try it on a mirror-perfect tree and a lopsided one. An empty tree is symmetric. Otherwise we ask whether the root's 2 children mirror each other. The mirror helper handles the empty cases and rejects nodes whose values differ. The heart of it. Outer meets outer and inner meets inner, crossing the 2 sides. Now let's test it and hit run. There we go. The first tree folds perfectly down the middle, so it is symmetric, and we get true. The second has a child hanging on the same side in both halves, so it does not mirror, and we get false. The mirror check goes like this. If both nodes are empty, return true. If only one is empty or the values differ, return false. Otherwise, check the outer pair and the inner pair, crossing left against right, and both must mirror. We compare every node against its mirror partner once, so the time is order n. The extra space is the recursion stack, as deep as the tree is tall, so order h, the height of the tree. 3 reminders. First, we compare the left side against the right side, crossing over not each subtree against itself. Second, remember the cross. The outer children pair up and the inner children pair up, and that cross is the whole trick. And third, matching values with a different shape is not symmetric, so always handle the empty cases carefully.